Okay, so let's give you guys some practice now. So here, find the linearization of of the square root of 1 plus x. So this square root of 1 plus x here is given by this red line here. So me asking you to find the linearization of the red line here at x equals 0. Sorry, me asking you to find out the linearization of the red line here. It's like me asking you to find out the equation of this tangent line at x equals 0. So me asking you to find the linearization of the red line, it's like me asking you to find out the equation of this tangent line here. Okay, so to find out the equation of any straight line, all you need to do is find out the gradient at that particular point. So the gradient at that particular point will be you having to differentiate this thing here, and then you need to know the exact coordinates at that precise point. So the coordinates at this precise point here is given by 0, comma, and then the y value here would be you putting the 0 into this thing here, and then the overall that would represent your y value here. Okay, so asking you to find out the linearization of the red line is really me asking you to find out the equation of this tangent line here. Okay, at x equals 0. And as a clue, the linearization, the equation of that linearization line, if you like, is given by this, and this thing here is really in a way similar to this mx plus c. So this is really like this, but in disguise. Okay, so these two are pretty much the same. Okay, and whenever you try and find a linearization of something at x equals 0, whenever you when x equals 0, it's a lot simpler. It will simplify things out greatly. So you finding out the linearization at x equals 0, it will simplify itself out. For example, when you look at this point here, you've got x take away 0, which is just x. Well, try it for yourself. You see what I mean? When you try and find the linearization of something at x equals 0, it will simplify out greatly. Well, anyway, press pause and have a go. Find the linearization of the red line here at x equals 0. Press pause and have a go. Okay, so to do this here, rewrite this thing here as to the power of a half. So f of x here, rewrite it as to the power of a half. So f of x here is that thing to the power of a half. Okay, so now we need to find out the gradient at that particular point. So we need to differentiate this. So when you differentiate this, the half goes down here, and then the power itself gets minus by 1. So that's this here. Okay, so the derivative is given by this, but we so this is the general case here. This is the derivative for all x, but we need to find out the gradient at x equals 0 at that precise point. So at x equals 0, we need to put this into here. Okay, meaning we also need to put it into here. So we need to know the gradient at that particular point at x equals 0. So at the gradient at x equals 0 is given by this thing here. So when you put 0 into here, it will be 1 plus 0, which is 1 here. So blah blah blah. The gradient at x equals 0 is given by this. Okay, so looking back at our formula for the linearization, the equation for that straight line is given by the gradient here at x equals 0 here. Okay, at x equals 0 here. At x equals 0. So the gradient. So this box here is what we just worked out. This box here. Hang on. This box here is really the gradient at the point at which we want to evaluate. Well, the gradient at that point would be a half. So we put this half into here. Okay. So the equation will be, well, we can put it at half here. Okay. And then bracket x minus the point at which we want to evaluate. Remember, we wanted to evaluate at x equals 0. So we put 0 into here. So that would be x minus 0, which is just x minus 0 is just x. So so we can just put this, okay. And then this f of 0 here, well, the f of 0 is really the well, let's look at this here. This is the coordinates at this point here will be 0, comma, and then this thing here. Okay, well, this thing here is really you putting the 0 into here, so it will be 1 plus 0, which is just 1. So the coordinates here will be will be 0, comma, square root of 1, which because when you put 0 into here, it will be 1 plus 0, and then you go to square root it will be square root of 1. So the square root of 1 is really just 1. So what I'm trying to say is that the coordinates at this point here is 0, comma, 1. Okay, so looking back at this here, this box here is really the y, is really this point here, the y coordinate of this point, which is just 1. So so which is just 1. So our equation for our straight line here is given by this. Okay, so hang on, let me just summarize here. You start out with this thing here. You need to know, well, differentiate it to get the gradient at x equals 0. So that would then give you this, and then blah blah blah. It would take you to here. So this is your gradient at x equals 0. So remember, looking at this equation here, put this into here, okay, and then you've got your x take away 0 here. So so that would then give you a half over, well, this thing here, and then this thing here is 1. Not very well explained, but forgive me.